Today I'm doing a speed run through all kinds of problems that occur in software development. This is our agenda today. I put everything into these slides here, so you see that's a whole grid of it, because it took me a couple of days to aggregate all of them. I've been coding software since I'm 16, 17, so now it's been 23 years. And I wanted to give a good overview of all the things that can happen in a software project and also give potential solutions. So alongside every problem, every symptom we have, we look into the underlying cause, and then we also look into what kind of solution we can have. And these are the kind of problems we have. I categorized them in why, when, what, and how, and with who, because they're distinct problems that start from the inception of a project, why we're working on something, the connection between the user and the actual development team. Then when is something where we are more about prioritization, what happens after another, what is the actual subject matter, and how is the process, and with who is usual people problems. So let's get right into that. We are starting with why. We want to know when we encounter a why problem, it's usually on the side of the product or of the stakeholders. So let's look into the first one. Something that sometimes happens is everything is considered important. So when a stakeholder says they need everything, and everything need to be perfect, usually it's a problem where the prioritization is not clear. And the potential solution are just validation, defining a product strategy, and then making that product strategy work consistently in work packages, giving that to the team. I want to say there is one caveat, something where it can be that actually everything is important. Let me explain this real quick. Sometimes you have a software that works through different steps, and all these steps are important. Let's say we had this case where we built a huge form builder software. So we had to work through a lot of forms because all this data was required to, in the end, give a result to the user. If that happens, then of course, let's say you don't have this information, you just cannot give it to the user. That is possible. If you encounter a problem like this, there's only one way in order to cut down the scope and make sure these things still get shipped on time. It is to cut down each individual contribution. Each individual package needs to get made smaller. And this could, for example, be just getting the UX smaller, making it somewhat simpler, but still containing all the information. Second problem, developers don't understand the business goals. When that happens, usually developers focus on the wrong stuff, and then they're not working on the things that actually make an impact. And that usually only happens if the priorities of the business or the business goals are not communicated well to the development team. The remedy, of course, is clear communication and also repetition, because I learned this from the book High Output Management. They said you should repeat something around 7 times. Before you have repeated something 7 times, it won't stick. So it's about repetition of what this thing actually should do, and then the developers have an easier time aligning towards those goals. Sometimes it happens that a feature just never gets done. And this can happen if the product managers have a certain estimation in their head, a certain thing that they think, okay, we will have that fast, we want to have it fast, it is important to us, but the developers don't see it like this. Usually the solution for these kind of problems is to bring the development team closer together with the users, and then they see what is actually important. I've heard of a company where every developer 1 day per month has to work in customer support. When that happens, then they actually see what is important to the user, and they have a much better picture of what to focus on when they work. This was everything to the why lane. Now we're going to the when. When is about problems that occur through prioritization or scheduling or prioritization. So let's go to the first one. We build up something that's a shortcut, and later on we need to rework it. This is a typical thing. It's called technical debt, and it's even something that can deliberately be done. Technical debt basically means you're taking a shortcut now in order to be faster now, but then of course later on you need to clean it up. To clean something up can have multiple solutions, but usually in a software that runs in production for the next years, it needs to get cleaned up at one point. Some solutions are you take the whole thing, the whole software, and trash it and build it new. But there are also other approaches where you have the team concurrently work on fixing and getting rid of this technical debt. And for example, it could be a cleanup day where on, let's say, every Friday, the whole team cleans up the software and make sure that all the things are updated and working in a better way. It's so-called refactoring. Also, a potential is to have a certain period where the whole team works on only refactoring, only getting rid of technical debt. And then there's, of course, this solution where there is a certain team to do only that. I've seen all of these approaches in my life as a software engineer, and I have to say there is no silver bullet. All of them can work, and all of them also have the potential not to work if they're not backed by the right people. The next point is, the next symptom that I want to talk about is that sometimes it happens that there is a module that is late and other parts of the app are done, but this one module is late. It just comes down, this is just a symptom of improper planning. And improper planning usually just comes from the fact that people don't know exactly how this thing will be built in the future. So you start in an agile way, you don't know all the information, you haven't looked at all integrations. Maybe there's something coming from the user side that you did not know before. So it's usually just something where we didn't understand something before, and now we have to deal with that. It can, however, be that this lack of understanding was possible to resolve before, and then it's just improper planning. So that needs to be made sure that those things don't happen again. So if there's improper planning, it shouldn't happen again. We should all get on the same page, and especially the stakeholders, they need to understand if a system has certain constraints, they need to know about them. And to emphasize this point, sometimes systems are very difficult to build, and only the developers know why they're difficult. There need to be a better communication between the leadership team, the users, and the developers. Another thing, integrating with third-party services can introduce unforeseen challenges and delays. This is something I've seen a couple of times now. It happens when there is something in the software that needs to integrate with another system, and this other system is like a black box. You don't know what breaks when you haven't used it yet. So once you start using it, then you see this thing is actually behaving in a very strange way. There's an API, or there's another microservice, or there's some people involved that you don't know before, and now you have to deal with that. Usually when there is an integration in a system, it needs to have a huge risk factor planned in. If this does not happen, then you're just working against a deadline that is kind of a wish deadline that maybe is just very risky to take on, just because there is some uncertainty that you have to embrace. So proper risk planning is super important in this case. Buffer times and a lot of research on the actual integration that needs to happen. Deadlines are missed and nobody knows why. This is just a thing of poor estimation and risk management. Just as I said before, if there's a deadline not being met, it can be that there's some third-party integration that you haven't really planned through. There is one solution, it's called the stagger charts, which are pretty cool. This is an example of a stagger chart that we work with. So every month we go into every software project and we estimate what we can achieve in the next months. So for example, this is a planning horizon of 5 months. And usually these things always get delayed a bit. It's just a question of how much they get delayed. The good thing is once we're here now, let's say here in December, and we see we have not reached this goal, then we can say, okay, let's say how far is it off? Is it 2 months off? Then we can try to get better at the next estimations. So stagger charts, it's a really good tool in order to learn how to be better at estimating. The next thing is what? So subject matter problems. And the first thing we have here is that, for example, the UX is too difficult and we're not pushing back. This is a common problem because UX designers love to make something pretty and they usually don't care so much about how fast it can be built. I've seen this many, many times where UX designers build something cloudy in the sky, something really nice, and then it's very hard to implement it. And there's only one solution for this: involve a front-end designer or involve someone who can develop, involve them early on and have them push back against the UX. Next problem. The developers work on a bike shed. A bike shed is something where, so it's a principle that you can look up on Wikipedia. It's actually quite interesting. A bike shed is something where, let's say a committee needs to talk about certain features on, in this case, it's a nuclear power plant. Nobody has an idea how to build a nuclear power plant, but everybody knows how to build a bike shed. There's a disproportionate amount of time being spent on talking about the bike shed than is talking about the nuclear power plant. Bike shed costs 100,000, nuclear power plant costs 100 million or $10 billion. But still more time goes into the bike shed. This happens for the developers as well. They see something that they can grasp or that they like, and they put way more time into this thing than into the actual really important features. And there's only one way out. The PMs need to control this. They need to make sure that the team gets pushed. And if they're not pushed enough, they can introduce deadlines to motivate them. I know this is a controversial opinion, but I'm a strong believer in deadlines. Next problem, a feature that we already estimated now takes long. And this is something that just always happens. And as a product manager, you need to embrace this, because estimations for software projects are usually always worse than, they usually always come out longer than they were initially estimated. This is just a rule of nature. You can mitigate this a bit. You can embrace that this gets slower, so you can add more buffer time, or you can do more research before you code. There is no generic solution for this, but it's very important to know this. And then we have this one symptom that I've seen a couple of times as well, where a feature gets shipped and then it's not complete. So someone accepted it, says, okay, it's great. They give it to the users don't like it, or something breaks and it comes back. This can happen, and usually only happens when there is a disconnect between the actual planning, the testing, and the development team. So it's what we need here is better acceptance criteria. And this could even mean better acceptance criteria often that means that the PMs need to know better what is required, because sometimes they don't know, and then they don't write acceptance criteria, and then usually the developers cannot actually deliver the right thing. The other thing I wanted to mention is it also makes sense to map the dependencies between subsystems. So sometimes you define something and you think it's great and you have all the acceptance criteria, but this thing has a dependency to another subsystem, and then things break. So as a PM, it's also very important to know what are the dependencies from the features you're currently developing. Next symptom, we're already at the how section. How is the process problem? So symptoms that appear inside the process. For example, development feels reactive, daily firefighting and burnout. This happens especially if developers don't see the exact goal, they don't see the exact motivation, and they only get fed one task at a time. This can work for some time, especially if you have a PM who's highly engaged. But usually it's better to have a bit more longer term goals, better planning, and also do this whole thing more coherently. Don't just give them one ticket to work at a time. Show them this is the goal we want to reach for the customer. These are the things we have to do along the way. And now you can pick the first thing. Next symptom. We want to do demos, but often we miss the demo day. And this is normal. This happens a lot, especially with smaller teams, especially if there's nobody exactly pushing on it, or pushing the development team to get the demos done. Solution is just repeat yourself again. It's basically just consistently pushing to get the demos out and then making it a habit. Usually those things don't work on the first try. We have to always motivate the team, always tell them we need this demo, and then they need to ship this. Another thing is that the shipping dates need to be a padding as well. So for example, if you cannot ask for a demo day in 1 day from now, it should be something that's rhythmic, where you say, okay, it's every Friday, we ship a demo to the clients or to the stakeholders. And then on a Thursdays, then there's feature freeze. And after that, it's just maintenance and bug fixing. Next symptom, devs cannot make proper estimations. We talked about this before. It's just a force of nature. It will always be like this. Developers will estimate 16 hours, and then they think 16 hours is a focused 16 hours, but in reality it's always more. It's hard to, we just have to deal with that. Okay, and then sometimes we have bugs in production, and also that's something I talked with my senior engineer. He said, this just happens. There's no way around it. You will have bugs. It's important to stay calm and to find ways to fix them. Especially during a production release, it's important to know who's there, who could fix things. So we would work in the team I was previously part of. We would make a schedule of, okay, we deploy on this day, and let's say Monday. And on Monday, on Monday itself there's a developer, on Tuesday there's another developer, and on Wednesday there's another developer during the holidays. So we would have exactly enough people to fix things if things break. And apart from that, also it happens to be beneficial to test more on staging, more automated testing and review code. So code reviews need to be done. If that doesn't work, it needs to be a process for actually good code reviews. And now we have the last section, the who section. Problems of people and communication. Team members too slow and I don't know why. This happens to the best product managers and they don't know why a team member is not performing, and usually it comes down to a skill level assessment. Maybe they don't know the skill level of that developer, or maybe the developer is a genius but they haven't worked with this exact thing before. All this happens, and I have other videos up there where I'm comparing my velocity to someone else, which you can check out on my channel as well. Skill level important, and then also setting clear expectations. Sometimes developers don't know if they need to ship something very fast or if it needs to be super high quality and super well tested. The expectations are important. Then sometimes there are problems of responsibility. I have questions, nobody answers it for me. So for example, a developer works on something and it builds on top of the work of someone else. Usually, you can find the Git repository, the Git logs, and you can figure out who worked on something before, and then you can reach out to them. But maybe that's not possible in this case, and then you need to reach out to someone. So that it needs to be clear who is there to help. If there's nobody to help, even especially junior developers, they would just take a lot of time to read all the documentation. They waste a lot of time, and then they come up with a solution that maybe works, maybe it doesn't. Clear responsibilities are important, especially also with training and who's there to help, who's there to fix code, who's there to do code reviews. And we have things like a symptom that I've sometimes encountered was that a stakeholder wants to have some information and then the team member gets asked and they don't know, then they ask the next person. Those things are just a problem of the actual information flow and the hierarchy. So we need to define clear roles and responsibilities in a document, and the document needs to get reviewed, ideally every week, so that everybody's on one page. And the last problem, a stakeholder asks about the status, but only the assigned devs knows. If that happens, it's just a problem of the process, meaning we need to create a clear ticketing system where all the tasks are there and the tasks are continuously updated. If they're not continuously updated, it's a lack of discipline on the developer side, and this can also be taught. What kind of problems have you seen in your career and which one did I miss? Let me know in the comments below. And if you just want to see the video where I compare my velocity to someone else, there's this video up here which you can check out.